Hello everyone, I am Dr. Padmavathi Vedula, AG Patil Institute of Technology, Solapur. I am here to explain Unit 6 of Engineering Mathematics 3, that is Functions of Complex Variable in Integral Calculus. Contents of this unit are Cauchy's integral theorem, Cauchy's integral formula, residues, Cauchy's residue theorem. So before understanding these concepts, we should know what is integration. So let us see integration of real valued functions, function of complex variable, concept of line integral first. So in this lecture, we focus on integration of real valued functions, function of complex variable, concept of integration of complex variable function, that is line integral. Let us solve some examples on line integral. So first of all, let us see what is variable. So the word variable itself says it is not constant. That means here if x belong to natural numbers at n, here natural numbers at n means n equal to 1, 2, 3 so on up to infinity. So if x belongs to n, x may be 1, x may be 2, x may be equal to 3 so on. So x is called a variable. Then what is real variable? If this variable x belong to real number set, then this variable is called real variable. If x comma y, these variables, if they belong to R, real number set R, then x, y are called as real variables. Then what is complex variable? We know complex number z. Z equals x plus iy. Here x, y are real variables. X, y belong to R. So if x, y are real variables, then x plus iy is called complex variable z. Then let us see what is function. Function is nothing but a relation between any two variables. So here if I write y equal to some x cube plus 1, this is relation between x and y. So here y is nothing but f of x. So you can write it as f of x equal to x cube plus 1. So this is relation between x and f of x. Here you can define this function in other way also. This relation is fx equal to x square, then according to this relation y contains 1 square, that is 1, 2 square 4, 3 square 9. So here this is relation between fx is nothing but relation between x and y, fx equal to x square. So here then what is real variable function? If this function contains real variables, if fx equal to some x power 5 plus 4x plus 3, this is relation between x and f of x. Here x is real variable, so this function is called real variable function. Here if we consider complex variable function, then complex variable function contains complex variable z. If fz equal to z square plus 1, then here the relation between f of z and z, this is nothing but a function. So we can define function as an expression in terms of given variable. Here fx means expression in terms of x. Here fz, here if you consider f of xy, this is function of xy, that means this expression contains x and y, both x and y variables. Okay, this is function of xy. So here this is only f of z, that's why here on right hand side we say an expression in terms of z. So here, but what is z? Z equal to x plus iy. So in the place of z, we can write x plus iy. So x plus iy whole square plus 1. If you simplify this, you get x square plus 2xyi plus I square y square plus 1. That means x square plus I into 2xy, here minus y square plus 1, since I square equal to minus 1. Here I square equal to minus 1. So here you get minus of y square. Otherwise you can write it as minus 1 into y square plus 1. So this gives x square, if we write all real terms together, here this is plus. Okay, so you get x minus y square plus 1 within one bracket plus I into 2xy. So here I have written all real terms in one bracket, then this is imaginary part. Okay, now this is equal to, if we say u plus iv, where u equal to x square minus y square plus 1 and v equal to 2xy. Then f of z equal to u plus iv is complex variable function and u is function of xy and v is function of xy. So we can write f of z equal to u plus iv. What is this? Complex variable function. Complex variable function or function of complex variable. Here u is function of xy and here v is also function of xy. Okay, so here this function is complex variable function. Now let us see what is integration. What is integration? We have studied integration in your 12th standard. So here in integration there are two types. What are those? Definite integration, indefinite integration. Indefinite integration and definite integration. So we can say like this, integration. Here this is integration of real variable function. Integration of real variable function. Here indefinite or indefinite. Definite and indefinite. So indefinite integration is nothing but reverse process of differentiation. So you can call this as antiderivative. Indefinite integral is nothing but antiderivative. That means if you consider integral sin x dx, integral sin x dx equal to minus cos x. If you differentiate this, d by dx of minus cos x equal to here minus of minus sin x, which gives sin x again. So reverse process of differentiation is nothing but indefinite integral. Then what is definite integral? Here a definite integral, if you consider fx, a function, a real valued function fx, which is continuous. Here if fx is continuous, if fx is continuous, over a closed interval AB. If fx is continuous over a closed interval AB, here fx is real valued function or real variable function. Real variable function. So if fx is continuous over AB, then integration of fx over AB is called definite integral. Then integral a to b fx dx is called definite integral. So here definite integration is over an interval AB. So if you consider this in other manner, if you consider x-axis and y-axis, This is origin. If you consider a curve f of x, then here this point is A, this point is B. Then area bounded by this curve and x-axis is nothing but definite integration of fx. Here if you divide this area into small rectangles, width of each rectangle is dx, then here area of one rectangle is nothing but fx into dx. Here fx means this height is nothing but fx. So here fx into dx gives area of one rectangle. Then if you integrate that from A to B, you get area bounded by this curve and x-axis. So here integral A to B fx dx can be represented in this manner. Okay. So you can define area bounded by the curve equal to integral A to B fx dx. So this integration is called definite integration. Then can we integrate complex variable function f of z? Yes, we can integrate complex variable function f of z. So here complex variable function. What is complex variable function? That is f of z. That function is in terms of z. Then we can integrate this f of z. Then here let us see, if there is any curve C, here this point is A, this point is B, some A equal to Z0, B equal to Zn, and Z1, Z2, Z3, so on, Zn, so on. Here ZR, ZR plus 1, so on, Zn. All these are points on this curve AB. Then if there is point here, this is delta ZR, between ZR and ZR plus 1. Here delta ZR is nothing but ZR plus 1 minus ZR. Then if you consider limit delta ZR tends to 0 and n tends to infinity, summation r equal to 1 to n f of lambda r delta ZR. If you consider sum of f of lambda r delta ZR along this curve, here on this curve, if this delta ZR tends to 0, then ZR plus 1 will come close to ZR. That means these points will be very closer when delta ZR tends to 0. Then n tends to infinity. That means here this number of points, if number of points tends to infinity and this distance between these 2 points, if that becomes 0, then this curve becomes a smooth curve. And then if you consider summation, then this summation of f of lambda r delta ZR, this becomes a continuous sum. So we represent continuous sum by an integral. So you can represent this summation by integral C f of z dz. Okay. So here integral means this is summation or integration along the curve C. This is called complex integration. Integration of a complex variable function f of z dz is usually called line integral because this integration is along this curve C. Okay, so this is called line integral of f of z along the curve C. So here integration is along the curve, not over an interval AB. Okay, so here if integration for real variable function, integration is over an interval AB, but here for complex variable function, integration is along the curve C. If integration is along the curve C, then to reach from A to B, there are infinite number of paths. That means here this is A to B, but you can reach B in this way also and in this way also. Right. So if this is curve C, if this is curve C1, if this is curve C2, then if you find integration along C1 and then along C and along C2, do you get same answer? No, that depends on the function f of z. If f of z is analytic function, then value of all these integrals, integration along C1, along C, along C2, all these answers will be same. But if function is not analytic, then the integral along C1, integral along C, then integration along C2, they differ. Okay, then let us see here. If f of z equal to u plus iv, if f of z equal to u plus iv, then what is about this integration? What this integration look like? Integral c f of z dz equal to dz equal to, here f of z means integration along c, here u plus iv into what is dz? Here z equal to x plus iy, then dz equal to dx plus I dy. So here you can write dx plus I dy. Okay, then what do you get? Integration along c, here u dx plus I into u dy plus I into b dx plus I square into b dy. If you multiply these bracket, we get like this. Now let us simplify this, which is equal to integral c, here u dx plus I into u dy plus I into b dx plus minus 1, I square is minus 1, b dy. That is integration along this curve C, u dx, here minus v dy, you can take here minus v dy plus I into u dy plus v dx. So here u is function of xy, v is also function of xy, here u is function of xy, v is function of xy, and xy are real variables, right? So here this integration of u dx minus v dy plus I into integration along c u dy plus v dx. So if you observe this integration of complex variable function here equal to this integral c into u dx minus v dy plus I into integration along c u dy plus v dx. So integral of a complex function fz is reduced to evaluation of two line integrals of real variable functions. Okay, because u dx minus v dy is real variable function. Here u dy plus v dx is also some real function. So here integration of complex variable function is reduced to combination of integrations of real functions. Okay, now path of integration. If path of integration is same, that means here if there is a curve, a path is like this from A to B, then if path of integration is same, if path of integration is same, then integral A to B f of z dz equal to minus of integral b to a f of z dz, and if C is a point, C is any point between A and B, between A and B, that means if there is some point C here, then integration along C fz dz, or integral a to b fz dz equal to integral a to c fz dz plus integral c to b fz dz. You can evaluate integral in this manner if C is any point on, if C is any point between A and B. Okay. Now, here, how can you evaluate these integrals? So, let us see working method. Working method to evaluate line integrals. So first point, observe given curve, observe equation of given path or curve, then convert integrand. Integrand may be in terms of x, or maybe in terms of xy, or in terms of z. So if integrand is in terms of z, then convert integrand into x or y terms. Then convert dz into dx or dy accordingly. Using equation of a given curve. Using equation of given curve. Then fourth point, change limits. Change limits from z to x or y accordingly. Then fifth, evaluate the integral. Evaluate. So first we have to observe given equation of given curve or equation of a given path. Then sometimes it may be a single curve or single equation, or sometimes here if path is like this, in this direction first, then in this direction, then here first we have to find integral along this OA, then along AB. Then we have to add both the values. So first we have to observe given path, then we have to convert integrand. If integration, that means if z square plus 1 some dz, if integrand is given like this, then you have to convert this integrand z square plus 1 in terms of x or in terms of y. Then we have to change even limits. If you convert integrand into x terms, then you have to find limits for x. If you convert integrand into y terms, then you have to find limits for y. Then you have to find dx or dy using given equation. Or here it means you have to change. If you want to convert variables in any given integral, you have to convert limits, you have to convert dz, and you have to convert the integrand into required variable terms. Okay, now let us see one question. First one is evaluate integral 0 to 1 plus I. Here x square plus iy dz along pi equal to x and along y equal to x square. Okay, so here let us solve this. So according to our working method, first we have to observe given equation of given path or given curve. So here first given curve is y equal to x. Okay, here first step we have to observe the given curve. In second step, convert integrand into x terms or y terms. Here this is not in z terms, this is already in terms of xy, but this is in terms of xy. So convert into x or into y using this equation. Here it is y equal to x. Okay, so x square plus iy can be written as x square plus ix. That means here we put y equal to x here. In this equation, put y equal to x. So we got x square plus ix. Now here what is z? Z equal to x plus iy, right? So we have to convert even z using this y. So here this is x plus ix. Here put y equal to x. Then you get x plus ix. That means 1 plus I into x. Then find dz. Dz equal to 1 plus I into dx. So we have converted given integrand into x terms, and here we have converted dz into dx. Now next step is we have to find limits. So when z equal to 0 implies x plus iy equal to 0. What is z? Z is nothing but x plus iy. If x plus iy is 0, that implies x equal to 0. Now, if z equal to 1 plus I, if z equal to 1 plus I, what does it mean? X plus iy equal to 1 plus I. That means if you compare these, x equal to 1. Okay, so x equal to 1. So here limits are from x equal to 0 to x equal to 1, and here integrand is x square plus ix and dz equal to 1 plus I dx. Then let us write this given integral in terms of x. So integral 0 to 1 plus I x square plus iy dz equal to integral 0 to 1, here x square plus ix into 1 plus I dx. So this is equal to 1 plus I integral 0 to 1 x square plus ix dx. Now integrate these two terms. So here 1 plus I into x cube by 3 plus I into x square upon 2 under the limits 0 to 1. So which is equal to 1 plus I into 1 by 3 plus I into 1 by 2. If you put upper limit x equal to 1, first we have to put upper limit, then lower limit. Okay, now if you put x equal to 0, you get 0. Then what do you get here? 1 plus I into 1 by 3 plus I into 1 by 2. If you multiply these two, 1 by 3 plus I into 1 by 2 plus I into 1 by 3 minus I square into 1 by 2. That means here 1 by 3 plus I into 1 by 2 plus 1 by 3 minus here plus I square. Okay, so this is minus 1 by 2. Okay, because I square equal to minus 1, you get minus 1 by 2. So 1 by 3 minus 1 by 2. This is 1 by 3 minus 1 by 2 plus I into 1 by 2 plus 1 by 3, which gives minus 1 by 6 plus 5 by 6 I. This is value of this integral. Now let us find value of this integral along the path y equal to x square. So here curve is y equal to x square. Then after taking equation of the curve, we have to convert integrand first. So integrand is x square plus iy. So which is equal to, here y equal to x square. So you can write x square plus I into x square, that is 1 plus I into x square. Okay, now let us find z. Z equal to x plus iy, which is equal to x plus I into x square. Then let us find dz. Dz equal to dx plus I into 2x dx. Then what do you get? 1 plus 2ix dx. This is dz. Now let us change limits. When z equal to 0 implies x plus iy equal to 0, that implies x equal to 0. If z equal to 1 plus I implies x plus iy equal to 1 plus I implies x equal to 1. Now let us see this integral. Now integral 0 to 1 plus I, here x square plus iy dz equal to integration of 0 to 1, here 1 plus I into x square into 1 plus 2ix dx. So 1 plus I we can write outside, integral 0 to 1 x square plus 2ix cube dx. So this is equal to 1 plus I into x cube by 3 plus 2I x power 4 by 4 under the limits 0 to 1. That is 1 plus I into, here if you apply limits, 1 by 3 plus, here you can cancel these two, here I into 1 by 2. Okay, minus, if you put x equal to 0, you get 0. That is here 1 plus I into 1 by 3 plus I into 1 by 2. Now if you multiply these, you get 1 by 3 plus I into 1 by 2 plus I into 1 by 3 plus I square into 1 by 2. That means 1 by 3 minus 1 by 2 plus I into 1 by 2 plus 1 by 3. Okay, that is again here, what do you get? This is 2 minus 3 upon 6 plus I into 3 plus 2 upon 6, which gives minus 1 by 6 plus 5 by 6 I. So here for this integral particularly, values of these the integrals, that means value of the integral along y equal to x and value of the integral along y equal to x square, both are same. Next question is, evaluate integral 0 to 2 plus I conjugate of z square dz along, first curve is along real axis to 2, then vertically to 2 plus I. Second curve is along the line 2y equal to x. Let us solve one by one. First one is, given curve is real axis to 2, then vertically to 2 plus I. What does it mean? If you draw real axis and imaginary axis, real axis x and imaginary axis y, then here what is given? Real axis to 2, that means this point, then vertically to 2 plus I. Here 2 plus I is nothing but ordered pair 2, 1. That means 2 is value of x, 1 is value of y. If you plot 2, 1 here, 2 is value of x. From 2 you have to go vertically to 1. This is 1. So this point is 2, 1, which is 2 plus I. So let us say this is A, this point is B here, this point is some O. Okay, so here this is 0, here let us say this point is O. So from OA, from O to A, so along OA, first we have to evaluate the integral along OA, then along AB. Okay, so after evaluating integral along OA and along AB, we have to add both the integrals. Now, along OA means it is on x-axis. So on x-axis y is 0. So along OA value of y is 0. Then z equal to x plus iy becomes 0. X plus 0i, which is equal to x. Then conjugate of z becomes x minus iy, that is x minus 0i, which is equal to x. Now conjugate of z whole square equal to x square. This is nothing but integrand in this given integral. Okay. Now after converting integral in terms of x, we have to find limits for x. Okay, here limits for z are 0 and 2 plus I. Now z equal to 0 means x plus iy equal to 0 implies x equal to 0. Here x plus iy equal to 2 plus I implies x equal to 2. Real part is 2. So x equal to 2. So here x varies from 0 to 2. Now dz, we have to find dz. So here we have obtained z equal to x. Z equal to x here. Z equal to x implies dz equal to dx. Okay, we have converted integrand in terms of x and we have converted dz, or we have evaluated, we have found dz in terms of x. So here dz equal to dx and we have taken limits for x using limits of z. Now let us write this integral. Integral 0 to 2 plus I conjugate of z square dz equal to integration of here 0 to 2 conjugate of z square is nothing but x square dz equal to dx. So here using integral x power n dx formula, that is x power n plus 1 upon n plus 1, using this let us integrate x square, then we get x cube by 3, but this is definite integration, so we have to apply limits. Here 2 cube upon 3 minus 0 upon 3. First we have to put x equal to 2 minus put x equal to 0. Then we get 8 by 3. Now along AB. Along AB, if you observe this line, along AB, value of x equal to 2. Value of x is fixed on this line, but y varies up to from 0 to 1. Okay, so value of x is fixed. So here on AB, x 2. Then z becomes z equal to x plus iy, which is equal to 2 plus iy. Then z bar, or conjugate of z, is 2 minus iy. Now conjugate of z square equal to 2 minus iy square, which is equal to 4 minus 4iy here plus I square y square, which is equal to 4 minus I into 4y here minus y square, since I square equal to minus 1. Okay, so this is equal to 4 minus y square minus I into 4y. This is conjugate of z whole square. Now we have to find dz, right? Again we have to find limits also. So here z equal to 2 plus iy, then dz equal to I dy. Now z equal to 0 implies x plus iy equal to 0, that is y equal to 0. Now z equal to 2 plus I implies x plus iy equal to 2 plus I into 1. Now compare these two. Here value of x is 2, value of y is 1. Here we need value of y, so y equal to 1. Here we have converted this integrand in terms of y. We are taking in terms of y, because value of x is fixed on AB. So by replacing x by 2, we converted z into 2 plus iy. That's why here we have considered dz equal to I dy. Here we have differentiated z equal to 2 plus iy, then we got dz equal to I dy. Then here we have considered limits for y. By using limits of z, here we have evaluated limits of y. Now integral 0 to 2 plus I conjugate of z square dz equal to integral 0 to 1. Here integrand is converted into 4 minus 4 iy, or 4 minus y square, 4 minus y square minus I into 4y dy. Let us check. Here integrand is 4 minus y square minus I into 4y, then into dz is I into dy. So in the place of dz we should write I into dy. Now this is nothing but integral 0 to 1 4I, or I you have taken outside the integral. Here I into integral 0 to 1 4 minus y square minus I into 4y dy. I have taken outside the integral. Now evaluate the integral. I into 4y minus y cube by 3 minus I into 4 into y square by 2 under the limits 0 to 1. Now apply upper limits first. So I into 4 minus 1 by 3 minus 4 into 1 by 2 minus, here when you apply lower limit, when you put y equal to 0, this whole expression becomes 0. So what do you get? Here I into, here sorry, I is left, here I, here 4 minus 1 by 3. So 12 minus 1 by 3 minus 2i, which is equal to I into 11 by 3 minus 2i. When you take this I inside, this is equal to 11 by 3i minus 2i square. Since I square is minus 1, you get 11 by 3i plus 2. This is value of integral along AB. Now, to get final answer, integral 0 to 2 plus I conjugate of z whole square dz equal to, here integral 0 to 2 plus I conjugate of z whole square dz along OA plus integral 0 to 2 plus I conjugate of z whole square dz along AB. So value of this is 8 by 3 plus value of this is 11 by 3 I plus 2. Now this is nothing but 8 plus 11, 8 plus 2. Here you have to add real parts and you have to add imaginary parts. So here this is equal to 8 by 3 plus 2 plus 11 by 3 I. That means 8 plus 6 by 3 plus 11 by 3 I. That is 14 by 3 plus 11 by 3 I. This is value of the integral 0 to 2 plus I conjugate of z whole square dz. Let us see one more example. Example 3. Integrate f of z equal to integrate f of z equal to x square plus ixy from point A 1 1 to point B 2 4 along the curve. Here parametric curve is given, x equal to t, y equal to t square. If parametric curve is given, we have to convert integrand in terms of t, then we have to find limits for t. Now integrand is, let us convert integrand first. Integrand is f of z equal to x square plus ixy. Now we have to convert this integrand f of z in terms of t. So here put x equal to t and y equal to t square. If you put x equal to t and y equal to t square, we get here t square plus I into t square. That is t square plus I into t cube. This is integrand. Now z equal to x plus iy. So to find dz, first we have considered z. Now dz equal to dx plus I dy. So to find dz, we need dx and dy. To get dx and dy, consider given equations x equal to t, then y equal to t square. Now dx equal to dt and dy equal to 2t dt. So let us put these here. So here dt plus I into 2t dt. So dz equal to 1 plus 2ti dt. This is dz. Now to get limits for t, we have to consider these points. Here curve is from A11 to B24. Here 1 and 1, these are values of x and y. This is value of x. This one is value of y. Here this is value of x, this is value of y. So either considering x or considering y, we can find limits for t. So here x equal to 1 and x equal to 2 here. But here x is equals to t, so implies t equal to 1. This implies t equal to 2. Here, since x equal to t. Since x equal to t, here t equal to 1 and t equal to 2. So limits are from 1 to 2 and dz is converted in terms of dt and even integrand we have taken in terms of t. So now let us find this integral. So here integral 1 to 2 t square plus t cube I into 1 plus 2ti dt. Now let us multiply these brackets first. So t square plus 2t cube I plus t cube I plus 2t power 4 I square dt. Now I square equal to minus 1. So if you replace that and if you add these two terms, you get 3t cube I plus 2t power 4 into minus 1 dt. That means integral 1 to 2, here t square plus 3t cube minus 2, here 3t cube I. 3t cube I or I into 3t cube minus 2t power 4 dt. So let us integrate. This is t cube by 3 plus I into 3 into t power 4 by 4 minus 2 into t power 5 by 5 under the limits 1 to 2. So first put t equal to 2, then you get 8 by 3 plus I into 3 into 16 by 4 minus 2 into 32 by 5. First we applied upper limit minus, when you apply lower limit 1 by 3 plus I into 3 by 4 minus 2 by 5. Let us simplify this. So here 8 by 3 plus here 12i minus 64 by 5 minus 1 by 3 minus 3 by 4i plus 2 by 5. Right. Now here 8 by 3 minus 1 by 3, that means let us simplify here. 8 by 3 minus 1 by 3 minus 64 by 5 plus 2 by 5, real part. The terms which are not containing I, we have considered all those. Here this is 7 by 3 minus 62 by 5. That means here 35 minus 186 by 5, which is equal to minus of here 151 upon 5. Okay, now consider these terms. I terms, here 12 minus 3 by 4, that is 48 minus 3 by 4, that is 45 by 4. So here final answer is minus 151 upon 5, here plus 45 by 4i. This is value of this integral. Okay. So this is integral 1 to 2 t square plus t cube I into 1 plus 2ti dt equal to this one. So in this session, here we have revised all those concepts which are required to understand forthcoming concepts. So in next session, let us discuss Cauchy's integral theorem and Cauchy's integral formula. Thank you.